Hi folks, welcome back to another Teardown Tuesday, and today we're taking apart an odd valve that I happened to find in our scrap pile. So it is a used part, it's been installed, and I'm not sure what it's from, but the labeling on it gives us some idea of where it came from. So the first thing I notice here is it says made in Italy. It's got a rating of 1/2 psi, and we're confirming that on the front here with the snout of the valve saying made in Italy. So we know this came from some kind of European equipment. We've also got some ratings in kilopascals on the side here and millibar on the side here. Taking a look at the way the valve is laid out, this looks like the inlet. This is called a saddle. And it looks like this saddle with this seal would sit on a manifold to supply gas into the valve. We've got a threaded fitting here, a threaded fitting here that looks like it's compression, and then a threaded fitting here that's probably a thermocouple. And looking down inside you can see it's got like a little isolated button. But when I try to thread a standard Robert Shaw thermocouple in, it does not match up to the threads in this valve. So whatever it's using for its pilot safety is not a standard threaded thermocouple. I suspect this is probably pilot gas. We've got a screw here that looks like it's probably pilot gas adjustment. And then we've got the stem for a knob to attach to. But in this case the stem has some indexing to it, so you can see it's got notches. I would guess this is probably the ignition position. You know, it sounds like there's a valve moving when we push that in, but it doesn't turn freely. It's got to move through this series of gates internally. So I'll be curious to see what's going on there. Once we get past a certain point on the knob, we're able to turn it back and forth, but we've got to move it in and out to get it to move through that range of motion. So let's start with trying to get this outlet off, and let's see what we can find from there. Alright, so we've got an O-ring seal, and then we can see down into the barrel here. So let's try moving that stem again, see if we can figure out where the open position is. So I think this is the off position. Then we move to safety. Yeah, so once we get past that you can see the barrel open up there. So these are the on positions. So this would be full heat or maximum heat, and that would be off or idle pilot heat. So let's take this front cover off now. So you've got a spring in there. Yeah, so that in the stem here they've got a pin and some grease, and you can see the pin has some limits that it's able to move through that stop it from rotating at certain points. So all that gating that we saw at the beginning there trying to turn the stem is done in this part of the valve, in this housing. So there's a pin pressed in here, and then there's a pin pressed in across down inside there. So you can see that hitting the different gates inside this part of the valve. Down in here, so we've got a spring with a rod down through the center of it. And let's see if we can get that worked loose. Oh, there it goes. Yep, so there's the small hole down through the middle. And there's the actual valve assembly itself. I would guess that that hole down through the center is for pilot gas control, because it looks like this slot in the side lines up with an opening into this side threaded fitting. So this would be the pilot, and our pilot gas control would happen at certain points in the rotation of this valve. So we turn it at a certain position, we start to get pilot gas flow. The interesting part though is I don't see the connection from our inlet, our saddle here, to this part of the valve. And it looks like maybe this pin, that pin goes down through and pushes another plunger down inside to let that happen. So let's get this part apart. Wasn't very tight. Wasn't very tight. Yeah, so we've got a little button down in the center there. Ah, interesting. Yeah, so you can see there's a little electromagnet coil down inside here. You can just barely make out that copper. And then there's a plunger with a seal on it. So it looks like when we depress the knob in to light the pilot, that pushes this plunger down, but there's a mechanism inside the barrel here. So once that pilot has warmed up the thermocouple, we'd get some voltage into this winding, and that would hold this down in. So once this is held in, now we have that gas flow from our inlet into the actual barrel part of our valve. Interesting setup. I've never seen one like this before. But that also means that we have gas around our coil here for our plunger. That's probably why they've got it sealed up the way they do. Interesting. There's not a whole lot in here that could really fail. The only thing that I see would be this electrical assembly for the thermocouple and the pilot safety, or possibly the grease drying up on our barrel here. Very straightforward though, very simple. So as far as concepts, we're starting to see the same concepts get used over and over again in these components. So here you see a spring. We've got tapers with some grease on them and some holes and openings to control gas flow. We're using electromagnetism to open and hold this plunger for the pilot safety. And we're using thermocouples with bimetals and heat to generate that voltage. So we've combined all those same concepts together, just in a slightly different way. Overall, a pretty interesting little valve. I've never seen a safety quite like this. All right, well, thanks for watching. Hi folks, my name is Jack Kell and I'm a Senior Technical Trainer for SmartCare. The video you've just watched is part of a larger series of technical training videos we make available to our technicians at SmartCare. If you found this interesting and you'd like to see more, please subscribe. I'll be releasing a new component teardown video every Tuesday in 2022. If you're already a SmartCare technician and you have a part that you'd like to see me tear down, please reach out to me internally for shipping instructions. If you're not a SmartCare technician, but you or someone you know would like to learn more about a career as a service technician specializing in commercial restaurant equipment, please check out our open positions at www.smartcaresolutions.com/careers. Thanks for watching.